Hi everyone. So in this video we are going to solve this particular problem. It was asked in GATE 2021 question paper, and wherever I saw the answer given was correct. Some solved it wrongly, but some solved it correctly. They gave the correct answer, but we will analyze the complete circuit. We will see what will happen from t equals to 0 to t equals to infinity for the given waveform. So just hold till the end and watch the solution. You will learn a lot of new things. I'm pretty sure you are going to learn a lot of new things which you haven't studied. Okay, so we will start with this question, but before that let's just clear the basics of a tangent. Okay, basics of tangent. Those who have studied the tangent part, they can skip this particular point and they can move to the question. We will move to the question, but for first 5 minutes we are going to solve this particular problem. So initially switch S1 is closed and S2 is open, and then at this particular time the switch S1 is opened and S2 is closed. So you have to draw the V0 waveform. Very easy question. So initially for 0 to ln2, for time 0 to ln2, RC ln2, what is the scene that your switch S1 is closed and S2 is open. S1 is closed and S2 is open. So minus 5 ut is there. And at the upper side there is 5 ut, right? So what is the initial value of V0? Initial value of V0 is capacitor is shorted, so it will be 5, and at infinity it will try to go to minus 5, right? So it is trying from 5 to minus 5. So we can write the V0 waveform. That would be, it is trying to go to minus 5 and initial value is 5. So this will be the V0 waveform. This will be the V0 equation, right? So initially it was at 5 volt and it was trying to go to minus 5. But will that happen? No, because at RCLN2 the circuit is changing at RCLN2. So at RCLN2, V0 value at RCLN2, what is that? If you put RCLN2 here, what you will get? RCLN2, you will get 0. Well and good. You can solve it on your own. You will get your V0 value to 0. So this V0 value is starting from 5, it was going to minus 5, but it will go till 0 only, right? It was trying to go to minus 5, it was trying to go like this, but this is not going to happen. It will just stop at 0. Just it has stopped at 0 volt, right? This time is RCLN2. This is V0 waveform. This time is RCLN2. Well and good. Now for t greater than RCLN2, what will happen? Now the input is the same, that is 5 volt only. This V0 is at 0. Now this is 5 volt, right? V0 is at 0, that means this would have charged to 5 volt. But we are caring about V0. So V0 at RCLN2, that is at 0, but at steady state it is trying to go to, at steady state it will try to go to, because at steady state capacitor will be open circuited, it will try to go to 5 volt, right? So basically we can proceed with this circuit only, we can proceed with this waveform only. So it is at 0 and it is trying to go to 5. So at steady state it will go to 5 volt. That's it. This is the waveform we will get, right? This is the same 5 volt. At steady state it will go to 5 volt. That's it. Well and good. So this is the waveform. This concept we are going to use in this problem only. So that's why I told you here. So basically, when there was this minus 5 volt, so V0 target was to go to minus 5. But after that, when it was 5 volt, now the V0 target became to go to plus 5. Initially, the target of V0 was to go to minus 5, from 5 to minus 5. But then suddenly, what happened is that the switch was changed. So now the target would become to go to plus 5, because at the steady state, the capacitor is going to be open circuited. If capacitor is going to be open circuited, the resistor will drive 0 ampere current. So whatever that is connected here, that would be the target of V0. Well and good. Let's move towards the question. So this was the question. Now 1 and 1 farad, these are connected in parallel. So I can 1 farad and 1 farad, 1 microfarad and 1 microfarad, that they are connected in parallel. So collectively it will be 2 microfarad, and this input waveform is given. So I can redo the circuit something like this, right? V in 2 microfarad, 10 kilo ohm, 12 volt minus 12 volt V0, and this is the input waveform. Well and good. Initially what is applied? Initially at t equals to 0, 5 volt is applied, right? At t equals to 0. Tell me one thing, will you say negative feedback is there? Will you say there is negative feedback, so there is virtual short valid? Certainly there is a negative feedback, but will there be virtual short valid? Can you say that this node will be 0 volt? Say yes or no. My question is, can you say at t equals to 0, this node will be 0 volt? No. Why so? Because capacitor is uncharged. This capacitor is uncharged, right? Let's just call this node as Vx. So if this capacitor is uncharged, whatever the V in voltage is there, that will be applied to Vx. Say yes or no. So Vx at t equals to 0 or 0 plus, you can say, that will be 5 volt. So this potential is going to be 5 volt initially. V negative is 5, V positive is 0. What will be the output voltage? Minus 12. Say yes or no. So V0 value at t equals to 0 plus, you are going to get minus 12. And this is what they asked, and answer was minus 12 volt. So everyone got the correct answer and everyone got the 2 marks. But let's just analyze the circuit. What will happen after that? So initially you understood the capacitor is having 0 voltage. So 5 volt is applied to the negative terminal. If 5 volt is applied, you V0 value you get is minus 12 volt. Say yes or no. No doubt about it. There is no virtual short valid. No concept of virtual short is valid here. 5 came. V negative is 5, positive is 0. It is simply acting as a comparator. No differentiator, nothing. People will say this is a standard differentiator circuit. No, nothing like that. We will discuss more about it. Just hold on to the end. We will discuss more about it. Now your output is saturated. Your output is there at minus 12 volt, right? If output is there at minus 12 volt, will the concept of virtual short valid? Concept of virtual short will be valid or not? No, because output is saturated. If output is saturated, your concept of virtual short is not valid, right? So I am going to write here, output is saturated. Output is saturated. So what does that mean? That virtual short not valid. Now if virtual short is not valid, then what will happen? So this is your V in. Here there is a capacitor. This is your V in. This capacitor is of 2 microfarad. Then there is this 10 kilo ohm resistance. This 10 kilo ohm resistance, and output is fixed at minus 12, right? Let's just say if I current is flowing from here, will this input of OpAmp will drive any current? No. So the same current will be flowing through this 10 kilo ohm resistance as well, right? This node is fixed. Output is fixed at minus 12 volt. This node is also fixed. V in is fixed at 5 volt. Here 5 volt is fixed. Here minus 12 volt is fixed. And there is same current in 2 microfarad and 10 kilo ohm. What do you think what will happen here? This has become a simple RC circuit now. Say yes or no. Output node is fixed and input voltage is fixed. So it has become a simple RC circuit. So let's just talk about this Vx node now. It is acting as first order RC circuit. Look, there is no use of this OpAmp. OpAmp, there is only one use of this OpAmp, that is that it is giving you constant minus 12 volt. Now the concept of virtual short is not valid. So what will happen to this Vx node? This is my question. What will happen to this Vx node? So for understanding that, we got to know that whatever the current that is flowing from 2 microfarad, that same current will be flowing from 10 microfarad. So it has become a simple RC circuit, series RC circuit. First order ORDER. First order series RC circuit. Right? It has become first order series RC circuit where Vx at 0 plus is 5 volt. But Vx at infinity, what that will be? At infinity, capacitor will be open circuited, so there will be no current through this resistor. So your Vx node is trying to go to minus 12 volt, right? So what is the target of Vx? Vx here sees 5 volt and then it is trying to move to minus 12 volt. This is the target of Vx. Vout is fixed at minus 12 volt. So let's draw the waveform of Vx. So what is the target of Vx? And let's draw the V0 waveform as well. This is your Vxt and this is your V0t. Vx. Initially Vx was at 5 volt and it is trying to go to minus 12. From 5 volt to it is trying to go to minus 12. Okay. And what about V0? V0 initially was minus 12 volt. Initially was minus 12 volt. Let's talk about this node. This node Vx. It is trying to go to 5 to minus 12. So initially it is at 5 volt. If this is at 5, this is at 0, output will be minus 12. Is there any doubt? No. After 5, from 5 to minus 12 it is going. From 5 to minus 12 like this. So after 5, what voltage it will get? Let's just say it is getting 4 volt. If it is getting 4 volt, what will be the output voltage? At negative node you are having 4 volt. At positive node you are having 0 voltage. Output voltage will be minus 12 volt only. Next moment it has moved to 0.1 volt. If here you are having 0.1 volt and at V0 you are having, what you will have at V0? Minus 12 volt only. Why so? Because negative node is at higher potential. At the next moment, let's just say it has moved to minus 0.1 volt. So what will be the output? Your Vx node was trying to go from 5 to minus 12. When it has moved to minus 0.1 volt, at that time, what will be the V0 voltage? When Vx is minus 0.1 volt, this node is at lower potential, this node is at higher potential. So V0 value will change to 12 volt. Say yes or no. So when Vx is equals to 0, when Vx is just going down to 0, when Vx is just going down to 0, your V0 value is changing from minus 12 to plus 12. At that moment, it has changed to plus 12. Now, what will be the target of Vx? What Vx is seeing? That, sir, this is my capacitor, this is my resistor. Now, Vx has gone to 0. It was trying to go to minus 0.1. But just as it tried to go to minus 0.1, here you got plus 12 volt. And this is your resistance R, this is your capacitor C, and this is your 5 volt. Okay. Now, what will be the target of Vx? Vx at some particular time, let's just say T1, it was 0 volt. Now, your output has become to 12 volt. What will be the target of Vx? The target of Vx will be to go to 12 volt. What was happening is that it was trying to go to 5 to minus 12 volt. But when it has reached to 0 volt, the moment it has reached to 0 volt, the output became plus 12. The output became plus 12, so the target of Vx changed. Now the target of Vx is to go from 0 to 12 volt. The target of Vx is to go from 0 to 12 volt. So now here the Vx value is 0 initially. Now it is trying to go from 0 to 12 volt. So let's just check it out. What will happen? Vx value is 0. Now the target is to go to 12 volt. So at the very next moment, where it will go? From 0 to it will go to 0.1. Say yes or no. 0 to 12 volt it was going. At the very next moment, it will go to 0.1 volt. If it goes to 0.1 volt, what will happen? The negative node is having higher potential, positive node is having lower potential. The plus 12 volt will immediately go to minus 12 volt. Say yes or no. From where we started? Vx was 5 volt, it was trying to go to minus 12. From 5 to it was trying to go to minus 12. It moved to 4, 3, 2, 1. There was no issue. It moved to 0.1 as well. There was no issue. When it moved to minus 0.1, there was the issue that your output changed. Just as your output changed, now what Vx will say? Sir, my target is to go to plus 12 now. Now if your target is to go to plus 12, then Vx node will rise. If Vx node is rising, then what Vx will say? That the next moment, sir, I will go to 0.1 volt. If Vx, the next moment it goes to 0.1 volt, then output will move to, immediately it will move to minus 12. Say yes or no. So here, let's just say at t equals to t1, At t equals to t1, it was at 0 volt. So till t equals to t1, it was at minus 12 volt only. At the very next moment, it goes to plus 12. It goes to plus 12. But at the very next moment, it goes to 0.1 volt. If it goes to 0.1 volt, at that moment only, it has to go down to again to minus 12. It has come down again to minus 12. Now, if it has come down to minus 12, what will be the target of Vx now? Vx is still at 0 only. It tried to go to 0.1, but let's just say it is at 0 only. Now, what is the target? The target is to go to minus 12 now, again, because at steady state it will be open circuit, so target of Vx will be to go to minus 12. So again it is trying to go down. From 0 to again it is trying to go down. If it again goes down, because it is at 0, the target is to go to minus 12 now. So if it is again going down, so the next moment it will go to minus 0.1. Say yes or no. If it goes to minus 0.1, again the output will change to 12 volt. So what is happening with Vx node? The Vx node, sometimes when it try to go to minus 0.1, what V node says that go to 0.1. Then it is going to 0.1. What V node is saying that come again go to 0. This is happening with Vx. Vx was at 0. It tried to go to minus 0.1. It was pulled up to 0.1. Then again it was pulled down to minus 0.1. Then again it will be pulled up to 0.1. Again it will be pulled down. So the Vx node will remain at 0 only. Say yes or no. Even if the output is saturated at minus 12, still it feels like that the concept of virtual short is valid here. No one will explain you this thing. I'm pretty sure in YouTube, in gate industry, that why the concept of virtual short is valid here. The Vx node started from 5. It was going to 0. When it was going to minus 0.1, it was pulled up to plus 0.1. When it was trying to go to 0.1, it was pulled down to minus 0.1. So this was your Vx node. Initially it was trying to go to minus 0.1. Then it was pulled up to 0.1. Then again it was pulled down to minus 0.1. Again it was pulled up to plus 0.1. Again it was pulled down. So it neither went up, it neither went down. It stayed at 0 only. So it felt like that the concept of virtual short is valid. Say yes or no. So Vx will remain at 0 only. And your output cannot go to plus 12, minus 12, plus 12, minus 12. It will not happen. What will happen to output, that we will discuss. So this was the most important point of this particular question, that Vx remains at 0. So it tried to go down, but then it remained at 0 only. Then it remained at 0. Now your output tried to go up to 12 volt, but will that happen? No. Why so? Because now your Vx node is fixed. Vx node is fixed at 0 volt. Your Vx node is fixed at 0 volt. So the voltage across the capacitor is fixed. Say yes or no. If the voltage across the capacitor is fixed, that means IC equals to C dVc by dt, right? If the voltage is fixed, that means current is 0, because differentiation will be 0. So if voltage is fixed, that means current is 0. That means from here 0 ampere current is flowing. If from here 0 ampere current is flowing, the same current is flowing here. So the same 0 ampere current will be flowing through the resistance as well. So this 0 will be copied towards the output. So what happened is that from minus 12, it will go down to directly 0. Immediately it will go down to 0. So this happened in the circuit. So this thing happened. Say yes or no. Did you understand this point? So quickly I will explain the thing, whatever that I have told here. Quickly I will revise it completely. Then I will write it down as well. So I will pause the video and I will write down everything. So we started with the initial structure. We saw that there is 5 volt. Then the 5 volt came towards the negative node. Then your output was minus 12 volt. If your output was minus 12 volt, then we got to know that your output is saturated. So the concept of virtual short is not valid. So now your Vx node will try to go to minus 12 volt. It is initially at 5. It is trying to go to minus 12 volt. It came down 5, 4, 3, 2. There was no issue. When it was trying to go to minus 0.1, there was an issue that your output moved to 12 volt. From minus 12 to it moved to 12 volt. If output is moved to 12 volt, then Vx node is trying to go up now from 0 to 0.1. If it goes from 0 to 0.1, output will again move to minus 12. then again output will move to plus 12, again minus 12, again plus 12. And what is happening with Vx node? Vx node 0, minus 0.1, 0.1, again minus 0.1, again 0.1. So it will not even move, it will stay at 0 only. If Vx node is constant, if Vx node is at 0, that means the voltage across the capacitor is constant. If voltage across the capacitor is constant, that means there is 0 ampere current flowing through the capacitor. This node is fixed at 0. There is 0 ampere current coming through the capacitor. So there will be 0 ampere current flowing through the resistance. So the resistance will have 0 voltage drop. So your output will be equal to 0 volt. Say yes or no. So IIT asked only here. They asked the voltage here. If they had asked the voltage somewhere here, then the question would have been interesting. We can find this value as well. We can find the value of T1 because what was the equation of Vx? Vxt. If I write the equation of Vxt, so it was trying to go to minus 12 with the initial voltage of 15 e to the power minus t by Rc. Rc value is what? 20 milli. T by Rc 20 milli. But at t equals to T1 it is 0. At t equals to T1 it is 0. So what will be the value of T1? That would be 20 milli ln 17 by 12. So we can find this value. by 12 ln into 20. So that is 6.9 milli. 6.9 milli. So this value is 6.9 milli. 6.9 milli. If IITs had asked what is the value of V naught at t equals to 8 millisecond, then what would be the answer? 0 volt. And a lot of, not just the teachers, not just the student, a lot of teacher would have got it wrong. Because I know they think that output will always be saturated. Nah, output is not always saturated. Vx node is not always going down. Vx node is stopping at t equals to T1. It is stopping at 6.9 millivolt. Whenever Vx node goes to 0, after that it cannot go down. It will stay there only, right? So it will stay there. But we will draw the complete waveform. After t equals to 20 millisecond, what is happening? So that we need to see. So we are going to draw the complete waveform. This is your 20 millisecond. Okay, so I will write down all the things, whatever that I have said, because as a teacher, I need to write down all the things. Then we will analyze the circuit after t equals to 20 millisecond, because after t equals to 20 millisecond, this input is gone. So we will see that. So I will pause the video and write down. Yeah, so I have wrote down all the things. For t greater than T1, Vx tries to go to negative, but V naught goes to 12 volt, then it pulls it up. It tries to go to 0.1, then again V naught goes to minus 12 volt, it pulls it down. So it doesn't go to 0.1, it doesn't go to minus 0.1. It stays at 0 only. And because it is at 0, then V naught will also be 0. Let's analyze the circuit for t greater than 20 millisecond. So this is our target. We need to analyze the circuit for t greater than 20 millisecond. So tell me one thing. Now for t greater than 20 millisecond, what is happening? Your input is gone. But what is the value of Vc for 20 millisecond minus? When there was this 5 volt input was present. When 5 volt input was present, this node was at 0, right? We have drawn the waveform. The Vx node was at 0. And this 5 volt was present here. So this was charged to 5 volt, right? This capacitor was charged to 5 volt. There is no issue about it. Is there any doubt? No. The capacitor was charged to 5 volt. So your VCT for 20 milli minus was 5 volt, right? This was 5 volt. Now your input is gone. If input is gone, but the capacitor is not going to change its voltage instantaneously, right? So VC 20 plus millisecond will also be 5 volt only, because capacitor doesn't change its voltage instantaneously. So this 5 volt is not gone. It can go slowly, it can go down or go up slowly, but instantaneously it will not go. So this 5 volt is there. If this 5 volt is there, that means what will be the potential of this point? Minus 5 volt. Say yes or no. And if this is minus 5 volt, what will be your V naught? V naught will be plus 12 volt. So your V naught at 20 millisecond plus is plus 12 volt. Say yes or no. What was happening? Your capacitor was already charged to 5 volt. The input is gone. The capacitor cannot lose its voltage instantaneously. So if input is gone, the Vx node will go to minus 5. If Vx node instantaneously go to minus 5, then your V node goes to plus 12. Now your output is saturated. Output is again saturated. If output is saturated, what does that mean? Virtual short not valid. Output is saturated, virtual short is not valid. So how does your circuit look like? This node is grounded. क्या बात है? Yes. Okay. This is resistance R. This node is at 12 volt. Again the same kind of thing is happening. This is 2 microfarad. Now the capacitor is charged to 5 volt. We are going to make comment on this Vx node, right? So Vx node at 20 millisecond plus, it is at minus 5 volt, right? Vx node. I am talking about this node. It is at minus 5 volt. It started from 5 to 0, then it stayed at 0, then suddenly when input is gone, it is at minus 5. What is the target of Vx? At steady state, this will be open circuited, right? At steady state, the capacitor will be open circuited. So what is the target of Vx? The Vx will try to go to 12 volt. Say yes or no. At steady state, this will be open circuited. Then this resistor will drive 0 ampere current. So this 12 volt will come here. So Vx at steady state, it will try to go to 12 volt. So now what is the target of Vx? From minus 5, it is trying to go to 12 volt. Now Vx node will move. From minus 5 to, let's just say it moved to minus 4 volt. Is there any issue at the output? No. Output will be at 12 volt only. There is no issue. From minus 4 to, let's just say it moved to minus 0.1 volt. Is there any issue at the output? No. Output will be at plus 12 volt only because V negative node is negative. That means V positive node is more. If the output moves to plus 0.1 volt, what will happen at the output? Output will say, I will go to minus 12 volt. If output goes to minus 12 volt, then what Vx node will say? Vx node will say that, sir, currently I am at whatever the time it is. Currently I am at 0, but my target now will be, since my output has moved to minus 12 volt, now my target is to go to minus 12. Currently I am at 0, but my target is to go to minus 12. If your target is to go to minus 12, then this node will go to minus 0.1. If it goes to minus 0.1, if Vx node goes to minus 0.1, again the output will go to plus 12. And if again it goes to plus 12, then target of Vx will be to go to plus 12 volt. If this is the target, then again this node move to 0.1 volt. Then again minus 0.1 volt. Again 0.1 volt. So again it has started going up, going down, going up, going down. So again the Vx will stop at 0 volt only. Say yes or no. Did you understand? Initially the Vx node was at minus 5. The target of Vx node was to go from minus 5 to plus 12. But when it reached to 0, it tried to go to 0.1. If it tries to go to 0.1, the output goes minus 12. If the output goes minus 12, the Vx will try to decrease. The Vx node will try to go to minus 12. If it is trying to go to minus 12, it will go to minus 0.1. If it goes to minus 0.1, the output will be at plus 12 again. So it is again and again toggling from 0 to minus 0.1 plus 0.1 minus 0.1 plus 0.1. It keeps on toggling and stays at 0 only. Say yes or no. So what will be the waveform of output? So this is how I can keep it so that you guys will be able to remember. And this I am rubbing. Okay. So I can keep it this way, that it tried to go to minus 0.1, then again it goes to plus 0.1, then again it goes to minus 0.1. So this way you guys will be able to remember that your Vx node from suddenly at 20 millisecond, since the input was gone, now some people can have one doubt. that sir input is gone and this node was at 0 only, I can say that virtual short is valid. No, 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 your virtual short is not valid. Here it was not the virtual short. This 0 voltage is not because of the virtual short. This 0 voltage is because the Vx node is fixed. It cannot go up, it cannot go down. It cannot pull up, it cannot pull down. So it has stayed there. It's not virtual short. It's not that this voltage is copied here. No, no, no. The thing is, it cannot move from that particular voltage. That's why it is fixed there. This is the reason. It is not virtual short. So you cannot say, sir, when the input is gone, this node will be at 0 volt. Nah, this node can change anytime. This node will certainly change. Because input is gone, then certainly it will come to -5. It will not be at 0 volt. Because some people will have some doubt that, sir, this will be at 0 volt, the capacitor will lose its voltage instantaneously, there will be some infinite current flowing, then output will change. Now that thing will not happen. Because there is no virtual short here. There is no virtual short. There is nothing like virtual short here, because whatever this is holding my +5 voltage and input is gone, so that this voltage will be copied here directly. Okay, so think if you have thought that there will be impulse current, that is good. That is also a good doubt. Some people can have this doubt, so I have cleared it, that certainly there will be no impulse current. The node Vx is not fixed. It can change anytime. So from here at 20 millisecond, the node changes very quickly to -5 volt. The node changes to -5 volt, and the time it changes to -5 volt, your V node goes to +12 volt. So this was the depth of this question, which no one covered. So I expect a good comment from your side and a good share from your side as well. Okay, so please do comment down how did you find this lecture or this particular video, because I know you must have understood a lot of new things, right? So this goes to +12 volt until the time it goes to 0. From -5 to it is trying to go to 0. From -5 to it will go to 0. How much time it will take? We can find out that time. After 0 it cannot go down and it will stay there. So till that time this will be +12 only, and after that what will happen? This 0 is fixed, 0 volt is fixed, this 0 volt is also fixed. This capacitor has discharged to 0 volt. This capacitor has discharged to 0 volt, the node are fixed. There is 0 ampere current flowing here, the same 0 ampere current is flowing here, and your output will be at 0 volt only. 0 volt. 0 ampere current is flowing, the same 0 ampere current is flowing through the 10 kilo ohm resistance, so output will be at 0 volt only. Say yes or no, right? But at the time when output is fixed, when the Vx node is fixed. Vx node is fixed at 0 volt, that means it is capacitor is driving 0 ampere current. If it is driving 0 ampere current, that means the resistor is also driving 0 ampere current, so output is fixed. Say yes or no, right? So at this time the output is fixed. Now what is that time? That also we can certainly find. How will we will find it? We can write down the Vxt equation. So it is trying to go to 12 volt. It is trying to go to 12 volt from initial value of -5. The initial value is at 20 millisecond divided by 2. 2 value is 20 milli only. So this is the same equation only. If you solve it and at t equals to t2, you can say that will be Vx2 will be equals to 0. Vx node will be equals to 0. So what will be the t2 value you will get? From here to here the time was 6.9. So again from here to here the time will be 6.9 only, because the same circuit is there, same time constant is there. It was going from 5 to 0, it is going from -5 to 0. It was trying to go from 5 to 12, it is trying to go from -5 to 12. So it was also trying to gain 17, it was also trying to lose 17. And the same time constant is there, so same time will be taken. So this will be completely symmetric. So what will be the time? 6.9 millisecond it will take, so this will be 26.9 milli. I don't even need to solve this equation. I can get to know that my T2 will be 26.9 millisecond. This will be 26.9 millisecond, right? And after that, it will remain there. The Px node will remain there as it is. So this was the depth of the question. I hope you liked the lecture a lot. We can draw the VCT waveform as well. We can draw VCT waveform as well. Everything we can draw because we are very intelligent, right? VCT, VXT we have drawn, VCT we are drawing. What happened with VCT? Initially it was at 0 volt, then your VX node was going down. That means your VCT node was going up. So it charged to 5 volt. It's charged to 5 volt. It's charged to 5 volt. How much time it took? To charge to 5 volt? 6.9 millisecond. Then it remained there. Then it discharges to 0 volt again. VCT discharges to 0 volt again. There you go. This is 6.9. This is 20. And this node will be 26.9. This is 6.9. This is 20 milli. This is 26.9 milli. Now this will be constant and it charges to how much voltage? 5 volt. So in the examination they could have asked anything, but they asked the very simple question. They asked the value of V naught here. IITs asked the very simple question. They asked the V naught value at t equals to 0 plus. But there was a lot of things to ask in this question. These are the final waveforms. They could have asked you anything. They could have asked you the value of V naught at t equals to 23 millisecond. The V naught value at t equals to 23 millisecond. That will be plus 12 volt. VCT value at 17 millisecond. That would be 5 volt. And they could have asked VCT value at 21 millisecond. Then you could have find from here, or you could have applied the equations as well, right? So it could have been very interesting problem, but they asked till this point only. But in the upcoming examination you can expect these kind of questions. At any point they can ask you any value. So I hope you will be very comfortable with that. Okay, so this was the question that they asked, IITs asked. Now I am going to ask you a question, that is this one. So I will put the link of my Telegram group in the comment section and in the description box as well. So you need to solve this problem. Simple CR circuit is there, the same circuit is there. The input is 5T UT now. You need to tell me the steady state V naught voltage. First condition you need to take RC equals to 3 seconds. The second condition you need to take RC equals to 1 second. And you need to tell me V naught value. I need the analysis. I don't need any Laplace transform minus RC integration or differentiation dV by dt. I don't know those things. I don't want that. I want an analysis. I want a simple analysis that how Vx node is going, what will happen to V naught. And since the input is ramp function, so it will be tough to find the value of Vx intuitively. So for finding Vx value only you can apply Laplace transform. Like it will be a simple CR circuit, okay? And since you get to know that Vin is increasing, so output will be saturated to minus 10, right? And here you are having Vin, that is 5T UT. And then you need the value of this Vx node. So for that now you can apply Laplace transform, because it is not like intuitively you can't tell what will be the value of Vx. For that you can apply the Laplace transform. So smartly apply the Laplace transform, you will see interesting results. But for the whole circuit you are not going to apply Laplace transform. I need the time domain analysis. Okay, Laplace transform to even our student can apply, because there is no intuition, there is no brain used. Okay, but we will use the brain because we are prep fusion student, right? Okay, yeah, so that's it. And if you like the lecture, please do share it with your friends so that it will help us to reach the students, because we don't have that much of subscriber. But I'm pretty sure, forget about the gate industry will not even deal these kind of questions. Forget about this question. Like there are thousands of teachers who claim to be the best. Like they claim as if, like some teachers claim that they teach better than NPTEL. Okay, some gate teachers, I am not taking the name. I have full respect for them, but these kind of comments they pass, and they can't even reach to this analysis. Okay, that is the harsh reality. I am really sorry if it is hurtful, but you need to accept it. Okay, and listening that you are better than NPTEL teachers, that was hurtful for me as well, because you are not better than them. Okay, certainly you are not better than them. You are not even 10% of them. That is the reality. I am not even 2% of them. But we all try. We all are trying, and we will keep on trying. So those teachers who pass these kind of comments, like, they cannot even do this analysis. So I hope, like, if they are having those much of followers, I am not jealous or anything, but I would certainly like if you follow this, if you share all those things, so that it may reach to the people, they realize what kind of analysis is being taught here and what kind of analysis is actually required in the gate examination. And if you are aiming to go into VLSI industry, these kind of analysis you need to do once you get into the industry and once you get into the M.tech as well. So I really hope you will be sharing. Okay, then thank you very much for investing the time. I hope I did not waste your time, and this was a fruitful session for you. Okay, then thank you.